In this video, we're going to take up the problems on practice part 2 for word and skeleton equations. So make sure you've attempted these first, and now you're just checking over your work, either with the answer keys provided online without video or with this video key. So solid zinc and aqueous lead nitrate react to form aqueous zinc nitrate and solid lead. So let's write a word equation. It says that zinc is reacting with lead 2 nitrate. That 2 just means the charge of lead is 2, because if you look in your periodic table, there's many charges for lead. There's 2 and 4, and it's just telling us it's the 2. So they're going to produce some zinc nitrate. And in addition to zinc nitrate, they're going to make some lead. Zinc nitrate and some lead as well. We can write a skeleton equation. So we have zinc in its solid state is going to be reacting with lead 2 nitrate solution, so PbNO3 2, and that was simply done by crisscross. It's solution, so it's aqueous. It's going to form zinc nitrate. So with crisscross, you get zinc nitrate like this, aqueous, and then some solid lead, so that's simply Pb with a solid there. And that's our skeleton equation. Let's try our next one. So aluminum bromide is going to react with chlorine gas. That's our word equation. That's our product to make aqueous aluminum chloride. That's one of our these are our reactants here. Now we're going to have our products, which are going to be aluminum chloride and bromine. To make our skeleton equation, crisscross the aluminum and bromine to make aluminum bromide. So AlBr3, and it's solid. We're going to make a react with chlorine gas. Don't forget, chlorine is a Hofbrinkel, so Cl2 gas, to produce aluminum chloride. So crisscross aluminum chloride, Al and Cl, and its solution says aqueous. And we made some liquid bromine, so that's Br2, it's diatomic and it's liquid. And there is our second problem. Fourth problem, a solution of sodium phosphate and calcium chloride react to form solid calcium phosphate and a solution of sodium chloride. So let's start with our word equation, nice and simple. The two that are reacting are sodium phosphate plus calcium chloride. They're solutions, but we don't write that yet. And they're going to produce some, if we have room to write this here, calcium phosphate plus sodium chloride. Again, we're not writing states or anything yet. We're going to be doing a lot of crisscross here. So sodium phosphate is Na3PO4 with your crisscross, right? If you don't remember that, please go back and watch the videos on ternary ionic compounds. It's also aqueous, so is the calcium chloride, crisscrossed as well, CaCl2aq, producing the calcium phosphate. When it's crisscrossed, we have Ca3PO4 2, and I believe it says it is solid, so that's a precipitate. And then we have our solution of sodium chloride, crisscrossed is simply NaClAq. And there we have it, that's our skeleton equation. Let's go to number 4, nice and simple one. We have potassium and chlorine combining to form potassium chloride. So potassium, we have chlorine, and they're performing potassium chloride. If we want to write that in skeleton equation, it says that we have potassium metal. It doesn't really say the state, but we can assume the metal is probably solid, because the only metal that's liquid at room temperature is mercury. We have chlorine gas. It's a diatomic element, so Cl2 gas. Potassium chloride, you crisscross it. It is crystals, so that's going to be solid. All right, our next one here, we have aluminum and hydrochloric acid reacting to form aluminum chloride and hydrogen gas. So we can do aluminum plus hydrochloric acid they're going to produce aluminum chloride plus some hydrogen. Again, word equations are very long, so it's nice when we have a skeleton equation we can write. So we have solid aluminum, Al, solid, plus hydrochloric acid. We gave you the formula because you didn't learn how to name acids yet, but once you do, you won't be given those formulas anymore. You'll notice that acids are aqueous, so we put AQ. It's going to produce the crisscross between aluminum and chlorine, which is aluminum chloride like that, and it says aqueous still. And then we also have some hydrogen gas made. Don't forget hydrogen is Hofbrinkel, so H2 and G. Then we're asked what the evidence of chemical change is. Take a look at what's made. You have a gas made. So it's probably going to be some bubbling because a gas is produced. All right, and we have two more to do over here. So again, you're checking your work. We have a solution of calcium hydroxide. Reacting with some more acid. So these are long ones, phosphoric acid. Arrow. Now what I'm going to do at the same time is I'm going to make my skeleton equation. Calcium hydroxide is a crisscross between calcium and hydroxide, which is CaOH2. And it says that we're aqueous because it's a solution. The acid formula was given to you because you hadn't learned a named acid yet, but once you do, it won't be given anymore. You'll notice that it's still a solution, so I'm putting aqueous as well. And it's going to produce some calcium phosphate, a solution of it. Plus some water. So when we do our crisscross, we'll get Ca3PO4 2. Should be a small 4, by the way. It's a subscript. It's a bit large though. It's aqueous plus some liquid water. Water, you know, is H2O. All right, our last one here, we have hydrogen gas and nitrogen monoxide reacting to form water and nitrogen gas. So our reactants are hydrogen plus nitrogen monoxide, and they're producing water when they react plus nitrogen. It says that a large amount of heat is produced, bringing the products to over 100 degrees Celsius. That's probably a clue for what the state of water is going to be. Let's take a look. So hydrogen is Hofbrinkel, so H2, plus, here we have to use our naming rules for our covalent compounds, nitrogen monoxide, that's NO, and it says that that was a gas. They produce water. Now because we're over 100 degrees Celsius, that's probably in gas state, so liquid, plus nitrogen gas, so that, remember, that's Hofbrinkel, so N2G. And so that is our skeleton equation for the word equation above. So please make sure you check your work. Review the crisscrossing and naming rules if you were unsure how to do crisscross from any of these. Really, the equations themselves are not that difficult. It's just about going back to review those naming rules and formula rules as needed.